Welcome to my short presentation about simplifying and automating doping control analysis by the use of online solid phase extraction. Methods of high quality are essential in doping control analysis. One of the key parameters is the required sensitivity and selectivity. The methods have to allow high sample throughput, and they have to be as general as possible to detect as many substances as possible in limited sample volumes. They also have to be cost efficient with a minimum of workload. Current sample preparation methods for doping control analysis use mainly liquid-liquid extraction, solid phase extraction, dilute-and-shoot, or a combination. Although dilute-and-shoot methods save time and work, they encounter some problems, for example retention time shifts and matrix effect. Therefore, an online SPE LC-MS application was developed, validated and evaluated as an alternative for the currently used methods. In this way, the advantages of dilute-and-shoot are combined with solving the problems related to it. Here you can see an animation of our online SPE system. It consists of two switching valves, a loading pump, an auto sampler, an online SPE column, a loop filled with methanol, an analytical pump, an analytical column which is connected to the MS, and a T-piece which combines the flows from the SPE and the analytical pump. In a first step, the samples will be loaded onto the SPE column. Our target compound will be retained on the SPE column, and the unwanted compounds will flow to the waste. In a second step, the valves switch. Now you can see that the loop is included in our flow path. The methanol will then elute our retained compound in backflush mode, and it will transfer the compound to the analytical column. The combination of both flows, so the one from the analytical pump and the one from the SPE, in the T-piece is very important to be able to focus the compound at the head of the analytical column. Then the valve switch again and the normal LC gradient is started on the analytical column. In the meantime, the loop is filled with methanol. The compound will then be eluted from the analytical column and will be analyzed by the MS. In the last step, the valves are switched back to their original position and the system will be equilibrated. On top of this online cleanup, we use a turbulent flow rate to load the samples, to clean them up even more. Comparing a turbulent flow rate and a conventional LC flow rate for the online SPE showed that the turbulent flow rate was more effective in removing matrix interferences. By applying an online cleanup, matrix effect and retention time shifts were reduced compared to a dilute-and-shoot approach. By using online SPE, we can replace individual cartridges by one online SPE column, which saves of course a lot of money. With our column currently on the instrument, over 7,000 samples have been analyzed without loss of performance. Here you can see the price difference between the offline cartridges and the purchase of an online SPE column. We chose for an Oasis HLB because it is able to trap compounds with different physicochemical properties because of its hydrophilic lipophilic character. There are some disadvantages attached to the use of the online SPE. For example, we can observe carryover by using the online SPE system. By applying a turbulent flow rate, a lot of solvent is being used. Because special equipment is needed and the setup and method development are complicated, trained staff is needed. On the other hand, workload is greatly reduced. Also, sample preparation time, retention time shifts and matrix effects are decreased. The use of one online SPE column is much cheaper than the use of separate cartridges. Next to the online SPE approach, the instrument can also be used for conventional LC analysis. And finally, this technology can be applied to a wide range of substances. In routine, the turbulent flow online SPE approach is used for the confirmation of 50 diuretics and masking agents, the confirmation of 80 stimulants, and for the screening and confirmation of 8 HIFs. By using the online SPE cleanup, sample preparation is reduced to taking an aliquot of urine, adding internal standard and centrifuging, and injecting the sample into the instrument. Currently, we are also looking into applying this technology for other classes of compounds on the prohibited list. All these developed methods use the same instrument settings and equipment, so there is no need to change the configuration of the instrument when switching between methods. I would like to thank my colleagues at DoCoLab, the PCC for the opportunity to present my research here, and you for listening to my presentation.